Welcome. Yeah, so problem 10 here, and up top in red here is a power reduction formula for integrals of this sort. And at some point, I'll dedicate a video to showing why this result in red is true. But of course, in this video, we'll need it to finish the given integral here, right? Okay, now to start this given integral, the first thing we should do is inside the parentheses here, get a common denominator. So if we do that, then I'm saying that we write this here. Now, this here, right, is the same as x squared plus 1 squared divided by x squared. But that's the same as having the x squared multiply the dx and dividing by x squared plus 1 squared, like that. Yeah? Okay, cool. Now, what we're going to do is to the numerator here with x squared, we're going to add and subtract 1. And so this is what I'm saying that we do in the numerator. Yeah? Okay. And so then, since this is the denominator, what we could do is split this quotient over this minus sign. That way we have x squared plus 1 divided by x squared plus 1 squared minus 1 over x squared plus 1 squared. Yeah? So I'm saying that, yeah, you should follow this. First we do this, which cancels to 1 over x squared plus 1, right? But then remember we have the minus 1 that we subtracted, and I just rewrote like x squared plus 1 in the denominator here as 1 plus x squared, as it might perhaps make it a tad bit easier to recognize that antiderivative. Okay, but then the rest of what we have to write is minus integral 1 over x squared plus 1 all squared, right? Okay. This here, right? And this follows naturally from what we had. Yeah? Okay, cool. Now, this here, right? Like this antiderivative is arc10x, right? Okay, so that's good. We reckon that. But it is here that we need this power reduction formula in red, right? Okay, so first let's write that we recognize that this is arc10x, right? And we can throw on the limits later, but then we have minus. Now, for the antiderivative of this here, we apply this formula in red where a is equal to 1 and b is equal to 1 and n is equal to 2. Otherwise, it's just executing this right-hand side with those three known constants, a, b, and n, right? And so if you do it correctly, first, as I said, it's that. If you do it correctly first, a little bit slowly, I write 4 minus 3 here because if n is 2 as it is, we get 2 times 2, which is 4, minus 3, which reduces to 1. I'll do the rest of the computation a lot faster. And so in the denominator, we should have what? 2 times 1, which is 2, and that's so because b is a 1, right? And then times n is 2, so 2 minus 1, which is 1. So we get just a 2, right? Okay, so that's 1/2 of the integral. The integral should be easier to recognize, right? Like, and since n is 2 here, n minus 1 here is going to be 1, and that's why, like, I just have that. Yeah? Okay, cool. So that's the integral part, and then, of course, we do plus this here. And again, you could be more careful about it as you're doing it, but I'm going to do it quicker. So here we are, and guess what? This antiderivative is also arc10, but 1/2 arc10, right? So what we're going to get is arc10x minus 1/2 arc10x, which is just going to become 1/2 arc10x, and then plus this, right? So I'm saying that this right here is 1/2 arc10x. So we get that minus 1/2 of that, and so we just get 1/2 arc10x, and kind of weird and funny that they share like this mixed color 1/2 appropriately, right? Okay. And so then we just have this fella, right? Okay, now that's just this. We have to use the proper grammar since this is an improper integral, and replace this infinity, say, with like a constant b, and write limit as b goes to infinity, right? And after all, like this integral, which is the same as the original, which is the same as these guys, ends up being this here. So we just evaluate this here at b, and then we evaluate it at 0, take the difference, and take the limit as b goes to infinity, right? So I'm saying that we write first this, and then next, right, that, because it's required, right? Like, that's the proper grammar. And if we speed it up, like, we get this, right, when we plug in the b. But when we plug in 0, we get 0 because arctan of 0 is 0, so we get 1/2 of 0, and then minus this numerator is 0, and so yeah, so I'm subtracting 0, but then no point in writing that. Now we just take the limit as b goes to infinity. Notice that as b goes to infinity, this here is going to go to 0 because the denominator dominates the numerator. And as b goes to infinity, arctan of b goes to pi over 2. You should look at a graph of arctan of x. But yeah, arctan looks like this, where like there's an asymptote, a horizontal asymptote up top here, and that's pi over 2. So as b goes to infinity, then arctan of b is going to go to pi over 2, and therefore this whole thing is going to go to 1/2 of pi over 2, and therefore pi over 4. Yeah? Cool. All right. So that's it for this video. Hope you enjoyed it, and keep watching. Take care.